Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the interview question, reverse words in a string. The question is on screen and it goes, given an input string, reverse the string word by word. So if we had the input reverse words in a string as our input string, then we were expecting an output of string A words reverse. So all of the words in the string in reverse order. So let's go ahead and look at how we would go about solving this in JavaScript. So first we would split the input at all of the spaces here to make an array of strings instead of having one big string. And then we would go backwards through the array and add each word backwards to a new string and reverse that new string. Let's go ahead and start building this out by making a function called reverse string. It's going to take in an string s as the input string, and then it's going to store the reversed string that we want to output. Initially, this is going to be an empty string, so we can declare it and initialize it just like that. And next, we're going to want to split our input string. So we're going to make a new variable called input string. And this is going to be equal to our input s.split, which is a method in JavaScript that allows us to split at a certain character at every instance of that character. So in this case, we're going to split at every instance of a space. This way we'll split at each word. Okay, so now we have two variables declared. What we're going to do next is loop through the input s and go through it backwards. So we're going to say for var I, which is our index, equals our input string dot length, which is the number of words that we have in our array, -1 for zero-based indexing. So we are starting at the final index in that array. Then we're going to go backwards. So while I is greater than or equal to 0, decrease I to go through each index, each word that we have stored in the array. And for each word that we have stored, we're going backwards and we're going to add it to our reversed string variable. So we're going to say reversed string plus equals the input string at the current index. And we're going to also add a space. This way, each word will be separated by a space in our output. Okay, that is everything we need for the solution. Let's go ahead and test this out by adding a console.log method just down here to print in the console. So let's go ahead and first print console.log reversed string, and then we can go ahead and console.log the reversed string itself. So every time this method runs reverse string, every time it runs, we are going to print reverse string and the string reversed. And finally, at the bottom of our code here, we can call the method itself, which is reverse string, and we can put in some input here. We can use the same input we used for our example, reverse words in a string. You can copy that right into the method here. Then I'm going to make sure that I close off my function just after the console.log, and then outside of that, I'm going to call reverse string on my input string. Then I'm going to hit run to test this code and just pull up the console here. And as you can see, I'm going to zoom into the console. We have here reversed string, and we have the reverse string A in words reverse, which means that this solution properly ran and we got our output. So congratulations everyone, you just solved this interview question of reverse words in a string in JavaScript. Thank you all for watching, and we're going to be continuing answering more questions in the next lecture. Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the interview question, rotate array. The question goes, rotate an array of n elements to the left by k steps. So here we're performing left array rotation. There's also right array rotation, which we'll briefly cover as well. So the input in this case would be an array of n elements, so any number of elements. For example, here we have 7 elements, and we want to perform a left rotation by k steps. So in this case, k equals 2, which means the output array would look like this. So what we're doing is we're taking the first 2 elements and we are rotating them to the end of the array, and then we are left with this resultant array here. Right array rotation would be where you take the final k elements, so the final 2 or the final 3, and you rotate them to the front. So those are the two differences between left rotation and right rotation. Let's go ahead and start building out left rotation. We're going to go through the array and use unshifting and splicing to solve this problem, as that is the most efficient in terms of time complexity. So what we're going to do is make a variable called left rotate, and this will be equal to a function, and it's going to take in an array as well as k steps. Let's go ahead and open and close this function immediately. So this array is our input array, and then k will be a number of steps to rotate by. First, we have to check the edge cases. So whenever you're answering questions, you always want to keep in mind edge cases. You may get specific constraints, like you may get a constraint that n cannot be more than 1,000,000, but that you must account for the possibility of 1,000,000 in terms of time complexity. So you have to consider edge cases. The edge case in this specific example is that we have to ensure that k is not greater than the n number of elements, because if k was something like 8, then we wouldn't be able to rotate it by that number of steps because there is not that number of elements. We could also take the number of elements and subtract it from k in order to get a k that would work. However, we're not going to be considering those for this solution. So let's go ahead and perform the check for the edge case. In that case, that would be making an if statement to check if k is less than our input array dot length. So k must be less than the number of elements. Then we're going to use the unshift method. So we're going to call the array dot unshift. The unshift method will add new items to the beginning of an array. So it will add the new items that we put inside of the parentheses to the beginning of this array and return a new length as its return. So in this case, we're going to be unshifting to splice the array. So first, we're going to turn the array into a list. To do that, we're going to use the spread operator, which is called with 3 dots here, and then the array name. So this will expand the array into a list, and this is available as of ES6. Okay, so we are transforming the array into a list, then we're going to splice it. The splice method will cut off elements from the end of an array. And in this case, we want to splice off k number of elements. So any value that you put in here, such as 2 or 3, this method will splice off that number of items from the end of the array. So in our case, we're going to put in k, that way we can account for variable values. Okay, great. So we're unshifting, which means we are going to add the new items that we're going to splice off. So we're going to splice off the last k elements and then unshift them to put them to the beginning of the array. Okay, that is all we need for that. And finally, we have to add an else statement, because right now we have if k is less than array.length. We also have to account for else. If k is greater than the array.length. In this case, we're going to make a variable called I for the index. I'm going to say while I is less than k, then we're going to use the unshift method again. So if k was, for example, 8, then in that case, we would go through from 0 to 8, and we're going to unshift again. And this time we're going to call array.unshift, and we are going to splice again. We're going to take the array and splice it by -1, which means we're going to take no values or -1 values and splice those. Okay, great. Then we're going to increment I, and finally we have to return a value for this function, and what we're going to return in our case is the array itself, because we've now modified the array, so we can return it and it will be returned modified. So we are going to return array. Okay, so now that is all we need for this solution. Let's go ahead and test out our solution by calling a console.log function. So we're going to call console.log, and we're going to call our method, which is left rotate, and this requires the parameter of an array as well as k, the number of steps to left rotate by. In order for this function to work, we are going to have to make a variable a and k, array and k, because right now we don't have those variables made. So let's use this example that we have up here and make an array that looks exactly like this with k equal to 2, because we know what the expected output should be. So this will be a good variable to test with. So we're going to make var array. We're going to initialize a new array, and we're going to set it equal to an array of 7 numbers from 1 to 7. Then we also have to declare and initialize k. So we're going to say var k equals 2. Now this method will work because we have initialized array and k. Let's go ahead and run this code by hitting the run button, and I'm going to pull up the console here. And as you can see, I'm going to zoom into the console here so you can see it. We now have our array rotated, and we have 3, 4, 5, 6, 7, 1, 2. So we took the first 2 items in the array and we left rotated them to the end of the array. Remember, right rotating would be to take the last 2 and move them forward. Okay, that is everything that we need to solve this interview question. Congratulations on solving the rotate array question in JavaScript, and we will see you in the next lecture. Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the interview question isomorphic strings. The question goes, given 2 strings A and B, determine if they are isomorphic. Isomorphic means that the string in string 1, you can replace all of the characters and get string B if you replace each character with a matching character. So for example, if you had the input ABC as string 1 and DEF as string 2, the output would be true because these two are isomorphic. You can replace every unique character in string 1 to get a string 2. Another example is input AA and AB, and in this case the output is false. The 2 strings are not isomorphic because you cannot replace all of the unique letters in AA to get AB. If you tried to replace AA with letters, then you would get something like BB or CC, but you could not get AB. So as you can see, we will have to perform checks on the characters, and the best way to do this in terms of time complexity is using a hash map to map the instances of each unique character. And in this case, the time complexity would be linear O of n. So let's go ahead and start building out a function to solve this problem. So we're going to make a function called isomorphic, and this function is going to take in string 1 and string 2 as the inputs. Okay, so this function is going to require a map, so let's go ahead and make a map called var hashmap, and we can make a hash map by opening 2 parentheses in JavaScript. Okay, great. So now we have a hash map, and this is going to be the map that will contain the characters. First, however, we can perform an obvious check to determine if the strings are isomorphic. See if you can determine what the obvious check would be. Well, it would be that the 2 strings must be of equal length. Because for example, if you had ABC as the first string and DEFG as the second string, then you obviously could not make them isomorphic because you could not replace all of the characters in string 1 to get string 2. So that is the first check we can perform. Let's go ahead and do that immediately. We can go ahead and check if string 1 dot length is not equal to string 2 dot length. Well, in that case, we can go ahead and immediately return false and exit the function, because that would mean the 2 strings are not isomorphic. However, if the 2 strings are of equal length, then we have to perform a check. So what we're going to do is make a for loop to go through each character in string 1 and compare it against string 2 using a map for efficiency. So we're going to say for var index equals 0 while index is less than string 1 dot length index plus plus. So we're making a for loop to go through each character in the string. We're going to make one variable to store the character in string 1 and another character variable to store the character in string 2. So we're going to make a var character 1 to be equal to string 1 at the current index. And then we're going to make var character 2 to be equal to string 2 at the current index. And now we're going to check if the character is not in the hash map, then we're going to put it into the hash map. And the key is going to be character 1 and the value is going to be character 2. Because that way later we can check if the character 1 key does not have the value character 2, then that means that these strings are not isomorphic. So let's go ahead and add that in here. We're going to check if the hash map does not contain a key of 1, a key of character 1. If the hash map does not contain the character, then we're going to set its key at that character 1 to be character 2. Remember, character 1 is the character in string 1 and character 2 is the character in string 2. Okay, and then we're going to check if the hash map at character 1 does not equal character 2. This can be an else. If the key at character 1 does not equal character 2, then we are going to return false because that means these strings are not isomorphic. Otherwise, if this never is entered, then we're going to return true outside of the for loop. Okay, so that is everything that we need to solve this question. Let's go ahead and run a test, and to do that we're going to need to call our function. So we're going to make a console.log and we're going to log our method, our isomorphic, and we're going to test it with our string examples ABC and DEF. Then we're going to call console.log on our isomorphic again, this time on AA and AB. We can also add one more check, and this can be on AA, on the string AA and the string BB, because that should be true. Okay, now I'm going to hit run and we can go ahead and pull up the console to check our results. So as you can see, we are getting true for the first result. We're getting true for ABC and DEF. Then we're getting false for AA and AB, and then we're getting true for AA and BB. So that means that we successfully performed a check and this solution passed. I encourage you to test it with more strings as you see fit. But other than that, that is all that we need for this solution. Congratulations on solving the interview question isomorphic strings, and we will see you in the next lecture. Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the interview question, kth largest element in an array. The question goes, find the kth largest element in an unsorted array. Note that the kth largest element is in the sorted order, not the kth distinct element. So for example, if we had an input of an array with the integers 3, 2, 1, 5, 6, 4. As you can see, it's unsorted, and we're given a k of 2. That means we want to find the second largest element in the array. So you'll notice that we get the output 5 because the second largest integer here is 5. Similarly, we have here an input 3, 2, 3, 1, 2, 4, 5, 5, 6. So this is another unsorted array, and we're getting this time the k value of 4. So we want to find the fourth largest element in the array. And in that case, it is going to be 4, because this is not the fourth distinct element, which would be 3, but it is the fourth unique element, which in this case would be 4, as the fourth largest. Okay, let's go ahead and look at how we would go about solving this. Well, whenever you hear or see in a question the terms largest or smallest, that is a signal for you to use heaps. Heap is a data structure that looks like a binary tree. So there are two types of binary heaps, the max heap and the min heap. The max heap is a binary tree where the values are stored in descending order, and the largest value is at the top, and then the values are descending in descending order. The opposite is a min heap, where the smallest value is stored at the top and the remaining values are in ascending order in a tree-like fashion. So how we can go about solving this is using a min heap, because we have here we're being asked for the largest element. So let's go ahead and start building a min heap. The best way to understand how min heaps and max heaps work is to start building one out. So I'm going to go ahead and start making a function down here. We're going to open up a function. We're going to call it find kth largest, and this is going to take in an array of integers and a k value because we're finding the kth largest integer. So first we're going to build a min heap. So we're going to make a constant called min heap, and we're going to make a min heap with another method which we're going to call create min heap. And this is going to take in an array. And we don't just want our array, but we want to slice the array from 0 to the k value. So you'll understand why we're doing this as we make our create min heap method. But what we're doing is we're putting inside the array sliced from 0 to k. So this is a useful method in JavaScript, slice, which it lets you slice an array from a starting value to an ending value inclusive. Okay, let's go ahead and build out this method that we need, a helper method called create min heap. So this is going to make our min heap. It's going to put this data from the first to the second element in terms of index into a tree-like format. So let's go ahead and build out that method just below. It's going to be a function create min heap. Okay, and this is going to take in an array, and in this method we're going to loop through each index. So for var I is equal to the array.length -1, we are going to use the sign propagating right shift operator to shift this by 1. And this is a bitwise operator, which is the equivalent of dividing by 2. So now we're going to, after that, check while I is greater than or equal to 0, I minus minus. So we're going backwards through the array because we're starting at the last index divided by 2, and then we are subtracting the index. And for each index we're going to make another method which is going to build the tree. So this method is going to be called perform heap, and it's going to need an array and the I index. And then finally this will return the array after it has been modified. So let's go ahead and build this second helper method called perform heap. It's going to be just below here, and it's going to be function perform heap. And it's going to take in an array as well as putting in I equals 0 and then making a value known as array at the current index. And we're going to need to use all of these three parameters to perform the heaping. Okay, so what we're going to do is say while true, so we're making an infinite while loop here, but we will break out of it. While true, we're going to say var x equals I times 2 plus 1. Then we're going to check if x plus 1 is less than array.length and the array at x is greater than the array at x plus 1. Then in that case, we are going to increment x. Then we're going to choose a child with the least value to make this heap. So to do that, we're going to open another if statement. We're going to say if x is greater than or equal to the array dot length, or the value is less than or equal to the array at x, then we are going to break. And finally, outside of that, we're going to say the array at the index will be equal to array at x. And we're going to assign the index to be equal to x. And then finally, outside of that loop, we're going to set the array at I to equal the value. Okay, so now we have our two helper methods set up. We can go back up to our initial method, and here we have to use our helper methods. So what we're going to do is, after we've made the min heap, we're going to say for var I equals y, while I is less than the array dot length, and actually this y is going to be k. While I is less than array dot length, and increment I each time, we're going to say if the array at I is greater than the min heap at 0, then we are going to call our perform heap method, perform heap on the min heap as well as 0 and the array at I. And finally, after that, we can return the min heap, because after we performed all of the heaping, the remaining one at the 0th index is going to be the kth largest element, because we have removed all of the ones that are not below k. So we've removed the, for example, if k was 2, then we would remove 6, and then we'd be left with 5, because we would have removed all the ones before that. Let's go ahead and perform a test by making a log. We can perform a test using both of these examples that we have here. I'm just going to paste this down here for reference. I'm going to make an array called array1, and I'm going to initialize it to this example. And then I'm going to perform console.log find kth largest on array1 and the k2, because we know we're expecting an output of 5 for this example. Then I'm going to make another test with const array2, which is going to be this array down here. I'm going to paste that in there. And I'm going to say console.log find kth largest on array2 and the value 4, because we know we're expecting a value of 4 for that one. So let's go ahead and hit run and pull up the console to see if we get the input we expect. Okay, looks like we forgot a semicolon on line 27. That's fine, let's go ahead and drop that in there. Okay, yes, we need a semicolon right around here. Let's see, we're performing a check for while it is greater than equal to 0 here. Yes, we have to add a greater than equal to 0 and a semicolon, and let's go ahead and hit run again. Okay, this actually needs to be a comma, and this needs to be a comma as well, so we can't have these semicolons there. Okay, excellent. Now you'll see the console will print 5 and 4, which is exactly what we expected, because we got the second largest value from the first array, which was 5, and the fourth largest value from the next array, which was 4. Congratulations, everyone. You just learned how to answer the question kth largest element in an array. Thank you for watching, and we will see you in the next lecture. Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the interview question, set matrix zeros. The problem goes, given a 2D matrix, if an element is 0, set its entire row and column to 0. Do it in place. In place means that we cannot make a new array. We must use the given array and not create a new one. We must manipulate the input instead. Okay, so let's go ahead and look at some examples. First, we have here an input of a 2D array. The first row has 1, 1, 0, 1. The second row has 1, 1, 1, 0. And the third row has 1, 1, 0, 1. At every element that has a 0, we will change the row and the column to 0. So the output for this one would be an entire matrix of zeros, because there are 3 zeros in the input. Another example is down here, where we have a 2D matrix with 1 0 at this element, and therefore we're going to convert this row to zeros and the final column to zeros as well, and the remaining elements should remain at 1. Okay, let's go ahead and start building out a solution for this problem. We're going to go ahead and make a function called set zeros, and it's going to take in that matrix, and we're going to go through each row and column and then set the row and column to 0 if the element itself is 0. So let's go ahead and loop through the entire row and column first. For var row equals 0 while row is less than matrix.length, increment the row to go through each row, and we're going to also go through each column for var column equals 0 while the column is less than the length of the row dot length, so the number of columns. Then we are going to increment the column each time. So now we have a for loop set up to go through each of the elements. We're going to perform a check. We're going to check if at the current row and the current column, if it is a 0, and if 1 divided by the matrix at the current row and column, that current element, is equal to infinity, then we're going to set the row and column associated with this element to 0, but none of the other rows or columns. So this is going to check if there's a 0 present as well as if there's another value that's undefined. So let's go ahead and go through each row. We're going to say for var x equals 0, while x is less than matrix.length, x plus plus. We're going to set matrix at x, and at the column equal to matrix at x, and at the column and to -0. So this will set it to the value, and then also check for if the value is -1. And if both of these return true, then the value is true. We also have to perform the same check for each column. So we're going to say for var y equals 0 while y is less than the number of columns, so matrix 0 dot length y plus plus. If that is the case, we have to perform a check for matrix at the current row and at the yth column. Then we're going to set the matrix at the current y column and perform a check for -0. So this will check both sides of this AND operator here. We'll check the condition, and if both are true, then it's going to set the value to true. Okay, so that is all that we need to set the rows and columns to 0. Now to actually test this, we're going to build out a matrix down here. Okay, so outside of our function, we're going to build our matrix. Let's use the exact same matrix that we had in the initial example, which was up here. We can go ahead and copy this matrix and paste it right in here as our example matrix. We're just going to move it all into one line here. And great, now we have a matrix. We're going to call our set zeros method on that matrix, and we're also going to print the resultant matrix. So in order to print the matrix, then we're going to make a new function called function print matrix, and in this case we are making a new matrix, but because we solved the solution in place, we are still meeting the requirements of the question. Typically with interview questions, you won't have to print out the result yourself. That will be already provided for you. Okay, but we'll do it quickly now. So we have for var row equals 0 while the row is less than the matrix dot length row plus plus. So we're going to again go through each row and each column, and we're going to print out the value of our new matrix here. It's still the same matrix, but it's after it's been manipulated. We're going to make a string to contain the current row, and then we're going to go through each column and put in the element into the string and print out each row. So for var column equals 0 while the column is less than the number of columns, increment the column to go through all of the columns. Then we are going to increment x, or add to x, the current element, and this will print it out. we will call console.log to print out the current row, and it will do that for each row. So that is all that we need to print the resultant matrix. Let's go ahead and run this code to test it. I'm going to pull up the console here. Okay, we're missing one extra semicolon here. So we can add a semicolon to close off this function. Yeah, we need an extra semicolon for this line right here. And that will remove all the syntax errors. So I'm just going to hit run again. And now you can see we have printed an array of zeros, a 2D array of zeros. Let's go ahead and use our second example to also test it with one more test case. So this time we're not going to be expecting an output of zeros. We're going to be expecting an output of several of the rows and columns changed to zeros, but not all of them. Let's go ahead and copy that input and make another var called matrix2, and we can make a new 2D array like this, and we're going to call set zeros again, this time on matrix2. Then we're going to call print matrix on matrix2. Let's go ahead and hit run and pull up the console, and this time we should be expecting the same output we had. Okay, excellent. So now we have, as you can see, we have our zeros, which is made the first matrix, and then we have this second 2D matrix here, which is the second matrix. And that is exactly the same output that we expected from the input in our example at the very beginning of the lecture. As you can see up here, those two match, which means we successfully solved this interview question. Thank you all for watching, and we will see you in the next lecture. Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the spiral matrix question, which goes, given a 2D matrix, return all elements of the matrix in spiral order. So spiral order means you go from the top row to the side to the bottom row, across the bottom row, in reverse, up the first row, and so forth on repeat until you've covered all the elements. So if we had a 2D array like this, a 2D matrix, then we would have to return 1, 2, 3, and then go down to 6, 9, 12, and then go to the side along the bottom row in reverse from 11 to 10, then up to 7 and 4, then to 5, and finally to 8. So we've done a spiral format like that. So let's go ahead and talk about how we can solve this. Well, there are several ways you can solve this. You can use for loops to go through each of the elements in the array. You could also use JavaScript functions, and that's what we're going to do in this course so that you know the JavaScript way. But there are multiple ways, of course, as with every interview question. Let's go ahead and open up a function. We can call this something like return in spiral order, for example. So we can call this, see, find spiral order, find spiral, or print spiral, might be better, print spiral order. Okay, so let's go ahead and put in an input as our input array, and we can also go ahead and put in a result array when we call the function, but this will just be an empty array to begin with. Okay, now we're going to check out the edge cases first. So the first edge case we can think of is that, what if we were given an empty array? If we were given an empty array, then we don't have to perform any looping. We can just print out the result of the array. So let's go ahead and check if input.length is equal to 0, then we're just going to return the result. And the result will be an empty array. So if the input is empty, we'll return an empty array. However, if the input has values, then we're going to start at the first row and add to the result. So we have our result variable up here, and we're going to add to it. So I'm going to say result equals result.concat. So this is the concatenation function, which will concatenate a value, add a value onto the result array. So we're going to concat on the input, and we're going to shift it. So this will get the shifted value of our array, and we'll put that into the result. And this way we'll add the first row of the input. This 1, 2, 3, we would add that first row to the result with input.shift. Okay, then we can go ahead and add the last element of each remaining row, because spiral order, of course, is going through the top row first, which we just did. So next, the step is to go through the last element of each remaining row, which would be 6, 9, and 12 here. So to get that functionality, we are going to call the input that we get, and we're going to go for each, to go through each element. And we're going to open up another function and get the last element there. So we'll call this last element. Last element. So for each last element in all of the remaining rows, we're going to call result and push in a value, and we're going to push in that last element dot pop. Okay, so this would be more descriptive if it was the row rather. So let's do row, because we're popping off the remaining, we're popping off the last element from the remaining rows, and we're going to go through each row of the remaining rows. Okay, so that will take that last element and push it into our result. So we're going through the spiral so far. I'm just going to close this off. And you also have to close off this function here with the parentheses. And yes, let's see. So make sure you leave it open like that, and then close it off down here. Okay, as the proper syntax, just like that. So now we have gone through 1, 2, 3, 6, 9, 12. So we have gone through some of the spiral. Now our next step is to go through the bottom, the final row of the spiral matrix, of the matrix. We have to go through the bottom row, but in reverse. So let's go ahead and do that next. So we're going to add the last row in reverse order in order to accomplish that. We just take the final row and concatenate it onto our result, but in reverse order. So to do that, I'm going to, let's see, I'm going to call result and add result.concat, and I'm going to take the input that is the input array and pop off the last row. Input.pop will take the last value in the 2D array, which is the last row, and it will pop it off, so it will return it, and it will also remove it, and then we can call reverse. So this will concatenate it onto result, but reversed, so in the reverse order. Okay, let's see. And finally, what we have to do is add the first element of each remaining row backwards. So we've gone through the top row, the side, the bottom, and now we have to go back up along the first element of each remaining row backwards through the rows. So to do that, I'm going to make a temporary array to store that. And we can solve this by calling our input array and going through each row again. So for each function, I'm going to say the row again, just like that. Hit a space to open that function like that. Oh, okay. And open up the function with curly brackets like this. Okay, and I'm going to bring that back up here for clear syntax. So we've opened up a for each loop to go through each row in the input. And what we're going to want to do is take our temporary array and push into it the row shifted. So that will get the first element in the row. And we are pushing it into our temporary array. So we've made a temporary array to store the first values remaining in the rows, the first element of each remaining row. After that, we can take our result, which we're returning, and concatenate onto it. And what we're going to concatenate is the temp array that we made with all the first elements in the rows, however also reversed, because as you'll remember, for the spiral matrix we have to go from the bottom up the first element in each remaining row, which means that we must reverse the order of the array that we have up here to go up like this. Okay, that would be the 4 and the 7 in that case, reversed to 7 and 4. Alright, and let's see, after that we are going to call the return keyword, and what we're going to return is our same method here using recursion. So we're going to call the same method, which we called print spiral order, and we're going to call it again inside of itself on the input and the result, which will be an empty array initially. However, this time it's going to be filled. And we're calling it again because that way we can go through all of the potential elements, because we still have the 5 and the 8 remaining. Alright, and that will ensure that we go through it back through all the elements. Because this is a simple 2D matrix, it doesn't contain that many values, which means we don't need many of the recursive loops. However, if this had 1 million values in its rows and 1 million values in its columns, then we get into much more need for time efficiency, and that is where we would have to recur a lot more. So that is something to consider. You'll always want to consider, are your solutions efficient for the potential length of your input? All right, so that's all we need to solve it. Let's go ahead and test out this function here. So I'm going to make an input that looks exactly like what we have up here. So I'm going to copy this input because we know we're expecting the spiral matrix to look like this. I'm going to copy that, bring it down here, and make a variable called input, and it's going to be equal to that 2D matrix that we have here. I'm going to space that out a bit better. So we are copying over our input that we have and storing it in a variable. And this is what we want to call our function on, to make a spiral matrix from this regular matrix. And what we're going to do is call a variable result. Let's see. And we can call our function here, which is, let's see, what would we call this? Print spiral order, yes. Print spiral order on the input and the initial result, which is just an empty array. And this will enter our function that we just made using this input that we have up here and using an empty array as the initial result, but then concatenating onto it, of course, and then recursively calling itself to go through all the elements up until the very middle ones. All right, and to print this, let's go ahead and call console.log and print result. I'm going to go ahead and hit run and pull up the console here. And as you can see, we have here printed 1, 2, 3, 6, 9, 12, 11, 10, 7, 4, 5, 8. So that is exactly the spiral of the matrix, if you look up here. For reference, we're going along the top, then the side, then the bottom, then the top in reverse, and so forth using recursion here. All right, so congratulations everyone on solving that interview question. Remember, there are multiple ways to solve this one, because as you can imagine, when you have a matrix, there are many different ways to iterate through these nested arrays with either iteration, recursion, or JavaScript functions as we used. Thank you all for watching. Congratulations on solving another question, and we will see you in the next lecture. Hello everyone, and welcome back to our JavaScript interview questions course. In this lecture, we're going to be solving the number of islands problem, a very commonly asked question. The question goes, given a 2D grid map of ones and zeros, with ones being land and zeros being water, count the number of islands. And it says also that an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So if we scroll down, we can see some examples of input and output. For example, here, I'll zoom in a little bit, we have an input of ones and zeros, and this represents the land and water. So land would be ones and water would be zeros. And as you can see, these zeros are connected all in one island here. All of the zeros are connected, so that means there's only one island here. Now if we scroll down to the other input, we have here ones and zeros again, but this time we have three different islands because we have these two connected as well as these up here. Okay, excellent. So let's go ahead and look at how we would go about building a function to solve this question now that we have the question all explained. We're going to build up a function. We can call this something like find islands, and it's going to take in a grid input, and we're going to need a constant called mark island, and this is going to mark every time we find an island, and we're going to set this equal to the function at the grid, and we're also going to need the row and the column and to check which array index we have visited. Okay, I'm going to open up this function here, and in here we're going to first look at all the edge cases, as you should for every question, and we're going to set as we visit each index in the array, and we're going to check if it's an island by counting the number of zeros versus ones that it might be connected to. So right now we have mark island here. We're going to first account for the edge cases, so that would be if the row is less than zero, or the row is greater than the grid dot length -1, or if the column is less than 0, or if the column is greater than grid at the current row dot length. So if the column is greater than the number of columns minus 1 due to zero-based indexing. Okay, so now we've accounted for this edge case. I'm just going to zoom out a little bit. Okay, so we have this function set up, and if one of these edge cases is true, we're just going to return undefined with the return keyword, because this should not be considered an island if we have invalid values here. Okay, we're also going to check if we visited the current index. So just below this if statement, we're going to put in if visited at the current row and at the current column equals true, then we are going to return undefined again. Okay, so let's also set the visited at each row and column to true initially equals true, because they should all be initially false as the default value, and then we're going to set them to true. And now we're going to perform a check if at the current grid, row, and column, if at the current index, if the value is 0, and note that we're using a character here instead of an integer, because that is what the question specified as well. A 2D grid map, oh, you could use integers, but typically this input would be in characters. That's why we are checking with this character format of these single quotation marks. Okay, we're going to check if at the current element it's 0, then we're going to return undefined. Okay, now we're going to check the bounds of the row and column and check if the current index is an island. And what we can do is if the row is greater than the number of rows or the column is greater than the number of rows, then there are 0 islands. And so we would set the current index to 0, and we would attempt to merge all of the neighbors of the current index. So let's go ahead and look at how we are going to do that. We're actually going to need to perform recursion with this method that we have here, mark island. Let's go ahead and add that in just below. We're going to call the same method, so we have our method here, find mark island, right here. This function we are going to use again. So we're going to perform recursion by calling it inside of itself. So just in here, right after that if statement where we have checked if the value is 0, we are going to mark island on the grid as well as all of its neighbors. So this function, as you can see, it needs the grid, the row, the column, and then visited. I'm just going to copy that here so we have it for reference and just put it down here, comment it out. So this is what the function requires in terms of parameters. So we need to check all of the neighbors. So we're going to check the row minus 1 as well as the current column, and we're going to put visited as the visited parameter for all of them. Visited we have here is our visited grid that we made. Okay, so we have visited. Now we're going to have to do this for every neighbor. So we're going to call mark island again on grid, and this time at row plus 1 and at the column and at visited. Similarly, we have to call mark island on grid and row this time and column minus 1 as well as visited. And again, mark island on grid, row, column plus 1 and visited. So this way we're going to go through each one and merge all the neighbors of the current index. As well, we're going to increment the number of islands. So let's go ahead and do that. First, we can close off this function and just delete that comment there. And just outside of here, so this time we're outside of the let mark island constant, and we're going to be still inside the find islands function. We are going to add in let visited equals an open array, and we're going to go through this. So we're going to say for let I equals 0 while I is less than grid.length I++. We're going through the entire grid. We're going to assign visited at the current index to be an empty array. So this will make an empty array at each row, and then we're going to count the number of visited indices in the grid. So we're going to make a constant for that. Let count equals 0, and this will count the number of indices we visit. So we're going to say for let row equals 0 while row is less than grid.length row plus plus. We can use a nested for loop for this as the best option. We're going to say for let column equals 0 while column is less than grid at the current row dot length. So we're going to go through each column inside of each row, and this will effectively go through each index in the two-dimensional array. Okay, so in the grid, the 2D matrix. So we have our for loops set up here. We're going to check if it has not been visited at the current row and column. So if visited is equal to false, and if the grid at the current row and column, at the same row and column, is equal to 1. Then this is going to be marked as a piece of land because it's 1 and it has not been visited yet. So what we're going to do is increment count and call mark island on the grid, the row, the column, and visit it again. As you remember, these are the parameters required for the mark island function. Okay, great. We also have to set visited at the current row and column to equal to true because that means we just visited it. Up here it was not visited, and then now we're setting it to true. And if it was true, then we're just affirming that it's true. Okay, and finally, after we have performed the looping through each of the elements in the grid, we're going to return the count. So return count down here. Okay, let's see. Now we can finally test this out. That is everything that we need for the solution. So we can go ahead and test this out with an example array. So let's see, we can use the examples we got in the input and the output down here. So we're just going to build a character array, a 2D grid map is what we have here. We're going to build a 2D grid map and then log it and then log our function on it, which is find islands, with that input grid as the parameter. And then we're going to print the output of that as well, because this whole function will perform the merging, the marking of islands, and it will return finally the count of the islands at the very end. So let's go ahead and do that. We're going to first make a 2D map, a 2D grid map. We're going to call it let map1 equals a new 2D array. So we can add semicolons or just like that to make sure we know where it ends. And here we can put in the same grid we had. So I'm just going to go up here and copy it over just to make sure we have it. And we know that for this one, we're expecting an output of 1. Okay, so we're just going to build this out for testing purposes. Now, if you're actually taking the exam for your interview, perhaps you're getting an online exam, then you won't have to test it out yourself because they'll have test cases. So they will provide you with their own setup here that you'll have to pass. And typically, first you'll have to pass 3 as the initial sample test, and then you'll have to pass about 10. And finally, in their own solution, once you've submitted your entire interview test, they will provide it on an even larger test case. But for our purposes, we can test it with our own sample set here, because the purpose of their sample sets is to test the time complexity, because if you're just working with small values like this, then you can use a simple algorithm that has longer time complexity. Whereas if you had a million different values in each row, for example, then you would need a more time efficient solution. So you would need more efficient time complexity for that solution. And that's what they will be testing you on their tests, and that's why they have such huge sample sets. But for our purposes, because we are watching out for time complexity or making sure we have the best possible time complexity, then we can use our sample set to test. And of course, you have to remember there's always multiple ways to solve each problem. It's more about the process and also how you iterate through your solutions. First you try one solution, you have certain time complexity, and then you iterate over that to optimize and find the best, most effective solution. Okay, so we have our first map here called map1. What I'm going to do is call console.log to map1. This will print the entire map just like this in the console here on REPL. Then I can call console.log, and with my function find islands, I can call map1 inside of that as the parameter. So that will return the number of islands in the grid. So we're expecting a value of 1 because, as we saw from the very beginning of this lecture, this should only have 1 island. As you can see, the zeros are all connected. They're not separated by land. So I'm going to go ahead and hit run and pull up the console here. And as you can see, I'm going to zoom into the console. We have here first printed our array, and that looks all good. Then we have 1 printed as the value, which means there's only 1 island. That is exactly what we expected, so we know that is correct. Now we're going to test it one more time with our second input here. As you remember from the beginning of this lecture, we have here our second input, and this time we're expecting an output of 3. So I'm going to go ahead and test this as well. Let's go ahead and scroll back down and we can build out another array that looks just like this. We can call it map2. I'm just going to go ahead and copy let map1 and change its name to map2 and quickly change in these values that it has here. So it has zeros here. As you can see, it has ones here, it has zeros here, so slightly different. Of course, you want to test with different inputs as much as possible. And whenever you're taking the real test, they will test you on at least 10 different test cases for sure. Okay, so we have our sample here. I'm going to delete this and I'm going to call console.log on map2 this time. Console.log map2 and then console.log find islands on map2, and we're expecting this to print out the number of islands there as well. So I'm going to pull up the console again, and as you can see, we have the first one printed, which is what we had initially, this one right here. Then down here we have our new map printed here with land and islands, and now we have a value of 3, just as we expected, 3 islands here. So that means that we successfully solved this interview question. The time complexity would be with the n squared, O of n squared, because we have these nested for loops. So I encourage you to try this out with more test cases. And thank you all for watching. Congratulations on solving this interview question. Questions like these are commonly asked. They may be modified slightly. For example, instead of asking for the number of islands, you might see count the number of countries that's commonly asked. They will use, instead of ones and zeros, they will consider them, they will call them countries. And they'll ask you for the number of distinct countries, etc. So thank you for watching up until now. Congratulations on solving this commonly asked question, and we will see you in the next lecture.